So this is a pretty important section. We're going to go over the properties for exponents, or sometimes I'll call them the rules for the exponents, or exponent rules. We use them later on in different parts of algebra, and so they're often referred to. So we'll go through them one by one. I think there's about 7 or 8 rules, and then we'll summarize them and give you some examples all along the way. So when we're talking about exponential notation, we're talking about having a base and then an exponent on that base. And what that means then is if you have a to the power of m, or a to the exponent of m, so this is referred to as either an exponent or a power exponent. It's a superscript, so it's raised up a little bit, okay? So it shouldn't look like a times m, but rather a to the power of m. And what that means is a times a times a, and how many times do you do that? M times. So if I have like b to the power of 3, or b to the third power, or you could say b cubed. Cubed is one of those special exponents. But what that means is b times b times b. Okay? So when I say special exponents, so you have like c squared, an exponent of 2, b cubed, an exponent of 3. Other than that, we just say to the 4th power, to the 5th power, whatever it is. Okay. So now we're going to talk about the product property. And the product property says if you have a base to an exponent times the same base but to a different exponent, or they could even be the same exponents, you're going to add those exponents. So you keep the base the same and you add those exponents. Okay? So the bases have to be the same. So maybe I have x to the 2nd power times x to the 3rd power. And then that's going to be equal to x to the 5th power. So we're adding those exponents. The bases have to be the same, and then you get that. Now why is that? Well, because x squared means x times x, right? And then x cubed means x times x times x. But see, it's all multiplication. So it's really x times x times, times x times x times x, which is x to the 5th power. That's supposed to be a multiplication sign there. Okay, so that's what's going on. All right, so here we have an example. B to the 9th times b to the 8th. The bases are the same. They're both b's, so you keep it a b, and then add the exponents. So think 9 plus 8, 17. Now you want to make sure you write that as a superscript, so it looks like b to the power of 17. Sometimes these are a little tricky to write. Okay, the next one. Base of 4, base of 4. So I can add the exponents. I have 2x plus x. So this is going to be equal to 4 to the 2x plus x. But we know how to add those. Those are like terms. That's polynomial stuff that we did before. 2x plus x is 3x. Sorry that screen pops up. I'm not sure why it does that. So, all right. Then we have one more. Oh, 2 more. Okay. So here we have an interesting situation. We have a 3 and we have a 4. Now it's 3 times p to the 5th times 4 times p. So I'm going to take the 3 and the 4 and I'm going to multiply those. And I'm going to think about the p to the 5th times the p. Now, when I just have p, that is understood to have an exponent of 1. We don't write the 1, we just know that it's there. You can write the 1 if you want to. Okay. So what is that going to equal? Well, 3 times 4 is 12. So I'm still multiplying like these coefficients. That's just regular multiplication. And then I'm going to have p to the power of 6, because 5 plus 1 is 6. So that was a really fun problem. All right. And then the last one, well, we have 3 bases. So x, 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 but they're all x's. So I'm just going to add all the exponents. And so this is going to be x to the power of 18. Because 6 plus 4 is 10, and 10 plus 8 is 18. Okay, That's that video.